So this is problem number 4 from your homework assignment. We're going to go over it. Now, we had to find all the zeros of this. Okay. So, we had to find all the zeros of this. Alex, how many zeros does this one have? Why? Because it's x to the 4th. That's right. Okay? It's x to the 4th power. So I'm going to have 4 zeros. So the first thing I'm going to do is I'm going to take and put this in my calculator and find out how many times this crosses the x-axis. Now, you guys, I had stat plots on my last class, so I want everybody to go right here to your y equals screen, please, right now. And I want you to go up and highlight that plot 1 and hit enter and go back down so it turns it off. Will everybody do that? Because otherwise, you're going to have problems with your calculator and you're not going to be able to graph this. Okay, so now we put this into our calculator, x to the 4th power minus 9x cubed minus 9x to the 3rd plus 21x squared plus 21x minus 130. I'm going to hit zoom 6 for a standard window. Now, it appears that this function crosses the x-axis twice. Right? Where does it cross it about? -2 and 5. Now, these could actually be slightly off -2 and 5. So we need to check to see if they are actually crossing right at -2 and right at +5. We can do this in a couple of different ways. One way is we can use the remainder theorem. We can do f of 5 to the 4th. I mean, we can go f of 5, which means we're going to put 5 in for x, right? So we're going to go 5 to the 4th minus 9 times 5 cubed plus 21 times 5 squared plus 21 times 5 minus 130. And see if I come up with what? 0. Go ahead and do that. Put that in your calculator. Oh, wow. What did I do wrong? Oh, I know what I did wrong. I put x's in there. And there must be a value stored in for x. I need to replace those x's. Okay, I get 0, right? My bad right there. Okay, so f of 5 equals 0, which means that 5 is 1, okay? Or the other way I can do this is I can use my calculator right here and go to my graph. And you guys, I can change the window if I want. And some of you guys might want to just to make it easier to find the zeros. But I want to show you a problem that everybody's been having. Everybody says, when they're trying to find the 0, they can't find the cursor. The reason they can't find it is because this line is, to the calculator, it's the points are so close together, it's highlighting the same pixels, and so it almost looks like a straight line. And when this calculator, when the cursor goes on it, it doesn't trace up. It traces to the next part where it jumps over a line of pixels, a row of pixels. And so when you do this, you got to watch your numbers, okay? So I'm going to go to second trace, go to 0, and right now, my cursor is at 0, negative 130 right here. You can see that by those numbers right there. So I'm going to go over and find, oh, we just did 5, so I'm going to go over and find the one over here on the left, the negative 2. So I'm going to hit the left arrow key. And I notice as I do this, here's my cursor. It's my y value is at negative 134, now negative 132, now 126. Should start jumping here really quickly. Negative 101, negative 80, negative 52, negative 16. So my cursor is just below here. And this next time it might even jump to be positive. Okay, it does. It jumps up clear up to 27. I'm going to go one more line to the left, up to 81, and I'm going to hit my enter for my left bound. It marks it with an arrow. Okay, now it's asking me for a right bound. I'm going to go to the right. Now I'm below it. I'm going to go one more below it. Put it down to negative 52. I hit enter. It marks my right bound. Now I'm going to go back one to the left. My cursor's at negative 16. It's clear down here somewhere. About right in here. I can't see it. And that's going to be my guess. I'm going to hit enter. And I get negative 2, 0. Okay, so there's my other 0. So I do know for sure that 5 and 2 are my zeros. What? Oh, yeah. So let's write this down. X equals positive 5 and x equals negative 2 are 2 of my zeros. Is that correct? Okay, so now we are going to use synthetic division. So if 2 of my zeros are real zeros, what does that make my other 2 zeros? Imaginary zeros. And how do we know once again that there's 4 zeros? Because it's 4th degree polynomial. Okay? So does it matter whether I divide 5 or negative 2 into this first? No, it doesn't. Which one do you want to do? Okay, let's put 5 in there. What are my coefficients? Let's go up here and look. They are, well, before negative 9. Oh, okay. 1, negative 9, 21, and negative 130. Okay. And I bring down 1, and I can start right here. I'm going to move this up. Okay, 5 times 1 is 5. Add, we get negative 4. 5 times negative 4 is negative 20. Add, I get 1. 5 times 1 is 5. Add, I get 26. 5 times 6 is 130. Add, I get 0. I should get a 0 there. Why? Because I know that for sure 5 is a 0, right? And so if it's a 0, I should get a remainder of 0, right? Okay, so I've now reduced my 4th degree polynomial down to a 3rd degree polynomial. This is 1x cubed minus 4x squared. No, 1x cubed minus 4x squared plus x plus 26, right? That's my new equation. But I've got to get it down to a quadratic because we know how to solve quadratic equations, right? And I have another 0. My other 0 is negative 2. So I just set up for synthetic division again. I'm going to go negative 2 times 1 is negative 2. Add, I get negative 6. Negative 2 times negative 6 is 12. Add, I get 13. Negative 2 times 13 is negative 26. Add, I get 0. Once again, I know that I should get 0 because negative 2 is a solution. We've already checked that. If I don't get 0, I know there's something wrong, and I got to go back and fix it. So now, I have the coefficients 1, negative 6, and 13. So what's my polynomial? Plus 13 equals 0, right? Good, Rhett. Okay, there's my quadratic equation. Now, we know how to solve quadratic equations. How do we solve them? Okay, what do we use to solve these? Okay, we do want to get the x by itself, but in this certain case, Yeah, we're going to probably want to use the quadratic formula or completing the square method, which you guys don't know the completing the square method, so we're going to just use the quadratic formula. Okay? You kind of know the completing the square, but it sounds like you didn't learn it much from last year. So we're going to use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I would definitely have that written on my 3x5 card for my next test. Okay, so we're going to plug these in. What is a, b, and c? Okay, so what's negative b going to be in my formula? X equals negative b. Positive 6. It's always the opposite of b. Since b is negative 6, we get a positive 6. Plus or minus b squared. What's b squared? Not what? Is it positive 36 or negative 36? It's always positive when you square a number, right? Minus 4 times a, which is 1, times c, which is 13, all divided by 2 times 1, which is 2. Now, what is 36 minus 4 times 1 times 13 simplify to be? Well, 4 times 13 is 52, so what's 36 minus 52? Negative 16. So we got 6 plus or minus the square root of negative 16 all over 2. What is the square root of negative 16? Not 4. 4i. Because it's a negative number, so we're going to have an I, right? So x equals 6 plus or minus 4i over 2. Will 2 go both into 6 and 4? So 2 will go into 6 how many times? And into 4. So my answer, 3, this is plus or minus. Plus or minus 2i. So my other two answers, well, let's list them all right here. We'll do it in black right here. X equals 5. X equals negative 2. X equals 3 plus 2i. And x equals 3 minus 2i. Those are my 4 zeros. Just trying to make you comfortable so you can have a good nap. We don't want everybody to see the drool on your paper. Oh. Okay. All right, so we know how to do those 4 problems right there, right? Yeah, I forgot. All right. Okay. Any questions on that? Okay, when's this assignment due? Next time. So finish those problems. Here was number 4. Make sure you get 1, 2, 3, and 5 done as well. Okay? Today's objective I wrote over on this board, and I have it right here. This one's actually probably better written right here. I'd write it down right here today. Write polynomial functions to model real-world data and interpret the data. Yeah, this is lesson 4-8. Someone asked me, why are we skipping so many sections in the book? You guys want to know the... That's exactly right. Because I'm following the core curriculum of the state. When textbook companies put together textbooks, they're trying to do it for every state. And they try to make money, so they include every single little thing in there. But our state core curriculum doesn't require us to do lessons 4.6, 4.7, and 4.4. So we're skipping clear up to 4.8. Okay? We did 4-5, and now we're doing 4-8. Okay, so what we're going to do today, and by the way, remember that we are having a test Thursday next week, 6 days from now. On Chapter 4, we will review on Tuesday. We'll also probably review a little bit before we take the test on Thursday. Okay, so we are taking the test Thursday. Then I'll grade them over the weekend, give them back to you on Monday. You can kind of know where your grade's going to be. If you don't do very well on the test, you might want to bring me extra credit in. By the way, did anybody bring extra credit today? Okay. If you're going to bring extra credit in, you got to give it to... Don't give it to me right now, though, Courtney. Okay, if you're going to bring extra credit in, it needs to be before or after school or class that you give it to me. Okay? So, and notice, when is it due? Next week on Friday, a week from today, it's the extra credit's due. Because that's when they're picking all this stuff up, the food and the sub for Santa stuff. Okay, any questions? Okay, so right now, I'm going to skip this one, and I'm going to come back to it in a second. I want you guys to look at this right here. We did this on our bell work today, but I want you to look at these right here. There are 4 types of polynomial functions that we're going to model data with. Okay, starting right here, the linear equations, lines, right? This is a typical line. It has 0 direction changes. You notice that once it starts up, it's going up. The quadratic, we all know, is a parabola. Parabola can go up or down. It has 1 direction change, from going up to going down. In other words, it has a maximum. A cubic function right here has a maximum and a minimum, or vice versa, okay? Or it might not even have a maximum and minimum, it might just go up. Okay, so this is a cubic function. And then a quartic can have up to 3 direction changes. And so those are the 4 types of functions. You're going to use one of those 4. You got 4 problems on your assignments today, and you're going to use one of those 4 on each of them. Only 4 problems on your assignment. Okay? Here's like the problems on our bell work right here. What does the first one model? Okay, it kind of looks cubic. It goes up, comes down a little bit, and then goes back up. What does the second one model? Quadratic, because it's a parabola. What does the third one model? Linear, because it's a line. Good. Okay? So, we're going to do this problem, and then I'm going to give you your assignment. You need to know how to do it. We did some of these at the first of the year using the calculator. So this is kind of a review of what we did, but we're going to use, instead of, the first year we only used lines. Now we're going to add to it all these other polynomial functions. So, take your calculator out. And we are going to put this data in. I'm going to tell you the data because you can't see it. But first of all, I want everybody to go to their y equals and clear everything out. Okay? Okay, next. We are going to go to second and y equals. Everybody go to second y equals to your stat plots. And we're going to turn number 1 on. So hit enter and hit the on button so it's on. Make sure that this type of graph is chosen, the first type, the scatter plot. Make sure the x-list says L1, the y-list says L2, and the mark is the very first one because that's the biggest. Okay, we got that? Okay, now hit your stat button. And if you remember right, the stat button is where we put the stats in at. So we go to edit, the very first thing, hit enter. And mine already has the stats in there. So I'd like you guys under list 1 to put the years. My first period class chose to put them in as 1980 and so forth. I suggested maybe doing 80 and then 85, 90, 91, 92, 93, but they wanted to do the full year, and that's fine. You could even start off at the 1980 as being 0, and you can go up from there. It's just that it's easier to calculate the years if you go up this way. Actually, this would be really hard to put the years at 19. You know what? You do need to put in 1980 because it changes into the 2000s, and if you just put the last 2 digits, you'll get 01 and everything else like that. Or you can do it as 0, 1, 2, 3, 4, 5, and so forth. Yep, 1990, then 91, 92, 93, 94, 80, 1980, then 1985, then 1990, then it goes up every year for a little bit, 91, 92, 93, 94. Let me see. 1986, 1995, 96, 2001. Yep. 2001's the last year. Okay, let me go to list 2. Okay, list 2, 1980 starts at 3.7, then 3.8 for the second one, 4.5, 4.4, and then 3 4.5s in a row. 4.5, 4.5, and 4.5 for 92, 93, 94. Yeah, 3.7, 3.8, 4.5, 4.4, 4.5, 4.5, 4.5. Then 4.4 for 1995, 4.3 for 1996, and then 4.4 for 2001. Okay? I'll make this bigger for a second if you can see this. Those are the numbers you're supposed to have in there. Okay? You need to have that data in your calculator, then you're going to know how to do this. Okay, are we there? Okay, so we want to set a window first. So we're going to hit our window button before we hit our plot. Now, our x-min, x-axis represents which numbers? The years, right? So what was our lowest year? 1980. So what do you want to set this at? 1979. I'm going to put it 1979. Good. Okay. What do you think we should put the x max at? Okay, 2005. That's a little bit beyond 2001. We might have to. So let's go 2005. Okay, what should we put our x scale at? We're going from 1979 to 2005, which is 26 marks. Usually, generally, 20 marks is the most you want to go. So maybe every 2? Or every 2 years. Because it's only 26 years. So put a mark every 2 years. Y-min, what do you think we want for our Y-min? 3.5? Okay, I like 3.5 because 3.7 is our lowest Y value over there. And what's our Y max? 4.6, okay. A little bit above. What do you think we should put our Y scale at? Well, 1, that's only going to put 1 mark there the whole time. I like 0.2 or 0.5, either one. Okay, good. Hit graph. And there's our data. Now, what do you think? Does that model anything? I kind of thought the same thing. It's kind of like linear in a way, except for right during these years, we wasted a lot. This is by way, this is pounds of waste per person per day, it's supposed to say. I put per year on accident. Per day in the United States. Do you guys know the United States has more waste per person than anywhere else in the world by like double the next closest one? Because they say we waste a lot over here. So anyway, we probably do. So it's probably because we have more money and so we have more disposable things. So, but they've been trying to teach us to cut down on waste because our landfills fill up fast and we're wasting natural resources. So, so this models that. It went up for a little while and it kind of went back down, but then it went back up, right? We could look up more data to see if it's changed since then, but we might do that. Okay? So right here, I've got to find a function that models this. I'll tell you the truth. Does anybody have an idea? There's almost no wrong answers here. Except there's probably one that's the wrong answer. But linear works pretty good, but it probably, it probably only, a linear one would go something like that, and there's some that are way off. We tried cubic in my first class. Let's try cubic. Let's do cubic. So this is how you do it, if you remember, right? You hit Stat, and you go over to the Calc menu. And cubic, which would be, cubic would be which one? Number 6. hit 6, and then it pastes cubic onto your home screen. You hit enter, and it will calculate it for you. Now, that's a lot of numbers to write down. You remember how we wrote them down before? Huh? So, you did something wrong. 6. Oh, yeah, you just got to go down here until calculate, and then you got it. Fix that error right there. There you go. Okay, so you're going to go stat, calc, 6. You're going to go clear down to there and calculate, hit enter. And there it is, okay? All right, now, guys, so we don't have to write this down because that's kind of big numbers. This is what I want you to do. Follow carefully. Go to your y equals screen. We're going to paste it to our y equals screen, so we got to start there so it knows where it's going to paste it to. And then you hit the one that says vars right here, right by the clear sign, V-A-R-S. And it brings all these things up. We're going to go to statistics, number 5. So hit number 5. We're going to go over to EQ. We're going to go to EQ, and we're going to hit EQ. And it pastes it to our home screen. Pretty nice, huh? Hit graph. What do you think about cubic? Well, here's what it goes. If you notice, that first coefficient was negative, so it's coming. The end behavior shows it's coming up down from the left. It goes down, it goes back up right here, and it goes down forever. How well do you think that fits the data? Let's do this. It wants us to make a prediction. Let's make a prediction for the year 19. Let's go 1987. There's nothing in 1987, right? So this is how you make a prediction. You're going to be doing this on your assignment. You go to your calc menu, which is above the trace. So you hit second and trace. And we want, which one of those things you want? Okay, number 1. We want number 1. Hit value, number 1. And you're going to type in the year, 1987. And we're going to make a prediction about it. And it gives 4.14. Or 4.15 if we round it 2 decimal places. Everybody write that down, 4.15. You go to second, trace, and you do value, the very first one. And you type in 1987 and hit enter. 4.15. Everybody write that down. Because we're gonna check it, we're gonna compare it to a quadratic here in just a second. Okay. Should we check one like 2003? Check 2003. So hit second, and trace again, go to value, and hit 2003. 4.18. 4.18. Okay, we got that? All right, now we're going to do this. Everybody go back to your home screen and clear that out. The book, we're going to do what the book says to do. And go back to your y equals and clear that out too. So we got that cleared out. Go back to your home screen. The book says that they think we should use a quadratic equation. So let's try a quadratic equation, see how much different it is from that cubic we used. So hit stats again. Go to calc. What do you mean, is it more of a square root? Well, it's going to be a parabolic looking. See, the cubic function that it just graphed looked like this, but our window, all we saw is this part of it right there. Does that make sense? Oh, square root. A square root function looks like this. We're doing a square function, which is a quadratic. Okay? I don't think it follows the square root one. Okay, go to calc. Let's go to quadratic, number 5. And calculate those stats. So here's the one for quadratic. Now we are going to paste that to the home screen, or to the y equals screen. So go to your y equals. Go to vars again. Go down to number 5, statistics. Over to EQ. And do your regression equation there. And hit graph. Let's do the same 2 predictions we just did. Let's predict 1987, you guys. So go to your calculate menu, go to value. And let's go 1987. 4.19. What did we get before when we did this? 4.15? So 4.19 is not much different than 4.15, right? We're like 4/100ths off, or maybe 5/100ths. Yeah, 4.2 then, huh? If we rounded, 4.2. So we're about 5/100ths off what we were last time. Or 10, yeah, 5/100ths. Okay, so that's not too far off. Let's go check out the other one. Go to second trace again, go to value. Let's put in what was it, 2003? 4.3. What did we get before on that one? 4.18, so it's a little bit different, right? 4.18 to 4.29, I guess. So we're about a 10th off. So if you would have used cubic or quadratic, that would have worked for that one. By the way, there's probably more than one answer on each of these. Okay? All right, here's your assignment. Show what? Yeah, I will. Write this down, and then I'll go back to that slide. Okay, here is your assignment. You got 4 problems. Now, if you haven't noticed, this takes the calculator. I had some people in my first class, I gave them 23 minutes to work on it. Oh, I'm giving you guys 42 minutes to work on it. We finished a lot faster in this class today. I had some people finish in 23 minutes, the 4 problems. So I'd expect you guys all to be able to finish this in class today, okay? So you need to work quickly on it because it requires the calculator to do it all. All I want you to do on all of them is to find the equation that models it using your calculator and make the predictions that it says to make about it. Got it? That's all you're doing. You're going to find the equations that model it, and then you're going to make the predictions. You're going to use the calculator to do everything.